Lesson 7.6, the inverse trigonometric functions. Okay, so let's think about this. Solve for theta. If you know theta is an angle measure measured in degrees between 0 degrees and 360 degrees. Okay, so if we're looking for the angle measure, if I want to know where the sine function is equal to 1, then you have to be asking yourself, where is my y coordinate equal to positive 1? Okay, I'm within one rotation around the unit circle because our domain tells us to look from 0 to 360. So where would our y coordinate be equal to 1? Up at 90 degrees. And that's the one and only answer. Number 2, where's your tangent function equal to negative square root of 3? Okay, so first we need to determine the reference angle. Okay, so what angle measure has a tangent value of square root of 3? That occurs at pi over 3. Okay, but notice now we're looking where the tangent is a negative value. So, putting it all together, your tangent is negative in 2 quadrants, and it occurs in quadrant 2 and quadrant 4. So using my reference angle, I switched to radians, I'm going to do that next. Using my reference angle of 60 degrees, okay, my 60 degree angle in quadrant 2 would be 180 minus 60 degrees. So one angle measure where the tangent is equal to negative square root of 3 would be 120 degrees. In quadrant 4, now 360 degrees is my reference axis. I subtract 60 degrees from that. So the other angle measure that would have a tangent of negative square root of 3 would be 300 degrees. All right, what angle measure has a cosine value of 2? There's no solution to this. Okay, the range of the sine and cosine functions are -1 to +1. So no output is going to be bigger than 1 or smaller than -1. Okay, where's your tangent function equal to 0? So we know our tangent function, that's our y coordinate over our x coordinate. So from our unit circle, again, where does our y coordinate equal 0? That occurs at 0 degrees. It occurs again, sorry, I keep going between the two. It occurs again at 180 degrees. And it occurs back at 360 degrees, but 360 is not in our given domain. So we would just include 0 and 180 degrees. All right, number 5, where's the sine function equal to negative square root of 3 over 2? So our reference angle is 60 degrees. Okay, the sine function is negative in quadrants 3 and 4. In quadrant 3, that's 180 degrees plus my reference angle. So at an angle measure of 240 degrees, your sine would be equal to negative square root of 3 over 2. And then in the 4th quadrant, 360 minus 60 degrees, which we looked at this angle measure already in number 2, would occur at 300 degrees. Okay, and lastly, where does the cosine now equal negative square root of 3 over 2? So that reference angle would be 30 degrees. Okay, cosine is negative in quadrants 2 and quadrants 3. In quadrant 2, 180 degrees minus our reference angle. So at 150 degrees is one angle measure. And then in quadrant 3, 180 degrees plus 30. So our other spot where the cosine would equal negative square root of 3 over 2 would be in the 3rd quadrant. Okay, so for homework, I would like you to solve these, but solve them now where your angle measure is between 0 and 2 pi radians. So all the work's done for you, the reference angle, the quadrants, the values. So attempt to do this by solving for theta strictly in terms of radians. Okay, so next, your inverse function. So think of what an inverse is. Okay, so the inverse of addition would be subtraction. The inverse of multiplication would be division. Okay, if we think of them in terms of solving, it's what we use to solve or undo a function. So notice your notation. inverse sine or arc sine, it means the angle whose sine is x. Okay, so if I'm looking at this, then x, my input, is going to be maybe my exact value, okay, from the inside of the chart, but it's the sine value of the angle measure. So then what's my output? So my output then is an angle measure. So arc sine of x is going to equal my angle measure. Okay, whose angle has a sine of the given value? Now, if we recall, in order for a function to have an inverse, it has to pass the horizontal line test. So if I draw a horizontal line through my graph of the sine function, it obviously fails it because it intersects it in more than one spot. I'm going to erase that line. So what we need to do is we need to restrict the sine function on a very specific domain. So if we look at the sine function just on the graph between negative pi over 2 and pi over 2. Okay, so if we just look strictly on that domain, okay, we maintain that the range is from -1 to 1. Now, if you think about drawing a horizontal line through any of that highlighted portion of the graph, it passes. So in order for an inverse function to exist, we have to restrict the domain. Now, over here, we've included the graph of the arc sine function, but the most important thing that I need you to recall, your domain and range on the graph of the inverse function switch. So what that means is the range of the sine function becomes the domain of the arc sine. The domain of the sine function becomes the range of the arc sine function. And this isn't going to make a whole lot of sense until we start doing problems. But if we think about evaluating, if my range is from negative pi over 2 to pi over 2, then I'm only allowed to answers in these two quadrants. And furthermore, my answers have to be angle measures between negative 90 degrees and positive 90 degrees, or in terms of radians, from negative pi over 2 radians to positive pi over 2 radians. Okay, cosine function, sort of the same deal. Fails the horizontal line test, so we have to look at the cosine function on a very specific domain. But now the domain for the arc cosine, we restrict it from 0 to pi. Okay, so we look on the domain from 0 to pi. The range is still from -1 to +1. So on the inverse or the arc cosine function, notice your domain and range switch. Okay, so my inputs have to be numbers between -1 and 1, and my outputs, my angle measures, can only be angles between 0 and pi or 0 and 180 degrees. So if we put that in terms of the unit circle, so now whenever we answer a question that involves arc cosine, our answers have to be in the first and second quadrants only, between 0 degrees and 180 degrees, or 0 radians and pi radians. All right, then lastly, the tangent function. There we go. So now the tangent function, this is restricted on almost the exact same domain as the sine. So we look from negative pi over 2 to pi over 2. But at negative pi over 2 and pi over 2, notice there's vertical asymptotes. Because at pi over 2, so tangent is sine divided by cosine. But at pi over 2, the cosine is equal to 0. We know we can't divide by 0, therefore giving us a vertical asymptote. So we look on the domain on the open interval from negative pi over 2 to pi over 2. But your range, your output on the tangent function is all real numbers. Okay, so there's no restriction on the y values. So when we go to look at the domain and range of the inverse tangent function, so now my inputs can be any number, but my outputs, my angle measure answers are going to be in the same two quadrants as the arc sine function, but we have to exclude the values on the actual y-axis. So from negative pi over 2 to pi over 2, we would exclude those y values, or negative 90 and 90 degrees. Okay, so let's try and do some examples. So arc sine. This is my domain. Okay, my domain is, my inputs can be any number between negative 1 and 1, but my range, my outputs now have to be angle measures between negative pi over 2 and pi over 2. Got this a little bit too close to my functions. Okay, so you have to ask yourself the question, where does the sine function equal a half? The sine function equals a half at pi over 6. That's my only answer, because my answers are only allowed to be angle measures between negative pi over 2 and positive pi over 2. Done. Secondly, arc sine function, where does my sine function equal negative 1/2? You're going to want to be tempted to write 7 pi over 6 or 11 pi over 6, because those are the two quadrants where the sine function is negative. We already know our reference angle is pi over 6, but because it's a specific arc sine function, your answer is just the opposite of your reference angle. Okay, and if we think of where that comes from graphically, negative pi over 6, I start at 0. Okay, I start at 0 and I just rotate pi over 6 degrees, or pi over 6 radians in the opposite direction. Okay, so where does the sine function equal negative 1? In this interval, the sine function equals negative 1 down here, so that would be negative pi over 2. Arc cosine is square root of 2 over 2. Okay, arc cosine is square root of 2 over 2. Where does the cosine function equal square root of 2 over 2? That occurs at pi over 4. Very easy. First quadrant answer only. So now recall, let's look at what the range of the arc cosine function is. So now where's the cosine negative? I have to look in my second quadrant here. Okay, and my answers are between 0 and pi, so how do I get my second quadrant angle? I take my reference angle, and my top number is my bottom number minus 1. All right, arc cosine of 0, so on this same interval, where's my cosine function equal to 0? It would only be up at pi over 2. Okay, so I'm going to add these problems for homework. So try and use the method and recall arc tan is on the same range as arc sine, but you can't include negative pi over 2 or pi over 2. So you're going to try those 3 inverse trig functions in addition to finding where these angle measures are in radians.